Hello again. So far we have done a lot of Rell programming, but Goblin Chess is a Unity project, and in Unity we program C#. Let's do a dummy .NET project that can talk to the Rell backend. But Unity doesn't use the .NET framework. It uses something called the .NET standard. I'm using Unity version 2022.2, and it depends on the .NET standard 2.1. which corresponds to a version 4.8 of the framework. My version uses C# 9.0. We start out by generating the project via the terminal. My machine is running .NET version 7, which isn't the same as 4.8, but it will probably work. Why am I using quotes around the .NET.exe command? It's because Windows likes to put spaces in their folder names. I use new console to create a new .NET project. Then I step into the project. I can compile with the build command and execute the code with the run command. As you see, the default implementation is just hello world. Now for the most important part, add package. We add the dependency to the Chromia C# client, version 0.6.5. POSTCHAIN is what a single node in the Chromia network is called. You can find information about the C# client at GitHub under Chain of Alliance. The game Chain of Alliance was the first Unity game based on Chromia, so the developers created this library. Why do we even need a client library? Can't we just send REST calls directly to the Chromia network? The problem is that the transaction must be signed, and unless you know how to do that properly, it's best to use a library. Choose Open Folder in Cursor and pick the new project. In the .csproj file, we see that the package got imported. I've written some client code already. Let's step through it line by line. First, import the Chromia namespace. In this case, we want to connect to a single node, the node that we have started on localhost. 7740 is the standard port. Like in episode 5, we find the blockchain RID in the logs of the node. Convert it from a string to a Chromia buffer. When we instantiate the Chromia client, we provide the URL and the chain ID. But on the real Chromia network, we wouldn't know which nodes are running the chain. So we would have used the create from directory method instead, using the port 7750. So what's the directory? The Chromia network consists of many clusters. The various clusters run different apps, but every cluster has a directory chain. So no matter what node you ask, it can point you to the cluster that runs the blockchain that you try to find. But for our tests, we don't need a directory. We know the URL to the only node that runs Goblin Chess. Let's create 4 key pairs and 4 names. The C# client uses the signature provider class to sign transactions. This class holds the key pair of the signer. The create method, without arguments, will create a random key pair. Transaction creation follows the same patterns as for automatic tests in Rell. We create an operation instance with the operation name and the player name as parameters. We use the client to create the transaction, where we also add the signature provider instance. The transaction now has everything it needs to sign itself. We use the client to send the transaction to the node. The await keyword in this case means that we don't want to proceed until the node has built the next block. We go back to the terminal and type restore. It's not really needed since we didn't modify the csproj file. When we run, we see the delay I was talking about caused by the await keyword. I only need await if I want to wait for the next block. Okay, let's continue with the test. Hopefully you remember that we have an enter lobby operation. I'm putting 3 players in the lobby. We can fetch the signature provider from the key pairs list that we created above. Create the operation object with the name of the operation and the game type for the given player. Signing and sending is the same as before. Let's make a query. The query method requires a generic type where we have to specify the return type. In this case, we'll receive the opponent's public key, and that will become a Chromia buffer on the C# side. As before, we send the query name as a string. Here, the arguments must be named, so each argument is a tuple. Perhaps you notice that we don't convert the C# types into Rell types. For primitive types, like string, integer, and bool, data conversion is automatic. And for the Rell byte array type, it will be automatic if we use the Chromia buffer type. Okay, now that Olle has found a player in the lobby, it's time to create the game. We send the found opponent and the game type as parameters. Sending the transaction is the same as previously. If everything went well, the player Pelle is now in a game. When he calls the in-game query, he should get an in-game struct back as a result. On the C# side, this translates into a dictionary. In the end, we print the result to the terminal. Let's run this test. In the right window, we have the node. Again, every time the node creates a block, we can see done printed in the left window, meaning that the await was finished. All this was just an exercise to reproduce our test in C#. The code in Goblin Chess won't look like this. In Goblin Chess, for example, the client will never have more than one signature provider representing the player. That's it. And now I think you have everything you need to create your own Chromia game. See ya!